Alright folks, here we go. We're going to start our solving these review problems for the quiz on section 7.2 through 7.5. These are the problems that were assigned. So we're going to start with page 396 with number 9. Alright, page 396. The problem reads, in a study of store checkout scanners, 1,234 items were checked out and 20 of them were found to be overcharges. We want to use a 0.05 significance level to test the claim that with scanners, 1% of the sales are overcharges. So here's our claim. Claim is that the proportion of overcharges equals 1%, which is 0.01. The significance level we're using is 0.05. And we are told that of the 1,234 items, so N is 1,234, 20 of them were found to be overcharges, so X is 20. So we're going to use one prop Z test. So we pull out our calculator and we hit stat, test, one prop Z test. Before we do that, we actually need to identify the null and alternative hypothesis. This opposite of our original claim is P does not equal 0.01. This is our null hypothesis. This is our alternative hypothesis. So now we can go back to the calculator. One prop Z test, the value of our null hypothesis is 0.01. X is 20. N is 1, 2, 3, 4. And the inequality that we should have highlighted is in our alternative hypothesis, not equal to. Hit calculate. And we've got our test statistic and p-value. Test statistic is 2.19. Our p-value is 0.0284. So now we can form our initial conclusion. We take the p-value and compare it to our significance level, 0.05. As you can see, the p-value is less than the significance level, so we reject the null hypothesis. Now we can write our formal conclusion. There is sufficient evidence to, and we're going to reject, because our original claim is the null hypothesis, we write reject the claim that, and then just restate the original claim. P equals 0.01. Alright, last thing we need to do is write the to calculate the critical value. And the critical value for normal distributions, we use inverse norm. Inverse norm. Since the critical value is in both tails, the alternative hypothesis lets you know where the critical values are at. And both tails, we use half of alpha. Alpha is 0.05 divided by 2. So let's go back to our calculator. Second vars. Let's see, second vars. Inverse norm is 3. And alpha is 0.05 divided by 2. So we have positive and negative 1.96. All done with that one. Next problem is number 11. That problem reads, In recent years, some professional baseball players complained about the umpires were calling more strikes than the average rate of 61% called the previous year. At one point in the season, umpire Dan Morrison called strikes in 2,231 of the 3,581 pitches. Use a .05 significance level, so alpha is .05, to test the claim. That the strike rate is greater than 61%. P is greater than 61%, 0.61. N for this problem is 3,581 pitches, of which 2,231 were strikes. So again, we use one prop Z test. I'm going to move that up here. One prop Z test. The opposite of our original claim is P is less than or equal to 0.61, but we're just going to write equals 0.61. This is our alternative hypothesis. This is our null hypothesis. And so now we go to one prop Z test in our calculator. Stat test, one prop Z test, and the value of our null hypothesis is 0.61. X is 2,231. N 3,581. And the inequality we should be highlighting is greater than. Hit calculate. And that's write down our test statistic and p-value. Test statistic is 1.60. P-value is 0.623. Now we can form our initial conclusion. We compare our p-value to the significance level, and as you can see, the p-value is greater than, is not less than or equal to the significance level, so we fail to reject the null hypothesis. We can now write our formal conclusion. There is not sufficient evidence, I'm just going to abbreviate it, to, and we're going to support the claim that, restate the original claim, P is greater than 0.61. Find our critical value and we're done. Critical value for normal distributions, we use inverse norm. Our critical value is in the right tail, so we use 1 minus alpha. 1 minus 0.05 is 0.95. Let's plug that into our calculator. Second vars, inverse norm, we have 0.95, and we get 1.64. Alright, all done with number 11. Let's go on to number 7. We're on page 404 now. Page 404. This is number 11. It's actually page 405. Cotinine levels of smokers. When people smoke, the nicotine they observed is converted to cotinine, which can be measured. A sample of 40 smokers has a mean cotinine level of 172.5. Assume that sigma is known to be 119.5. Use a .01 significance level to test the claim that the mean cotinine level of all smokers is equal to 200. Here's our claim, that the mean cotinine level of smokers is equal to 200. Alright, significance level that we're using for number 11 is 0.01. And we're told that we have 40 smokers. The mean cotinine level for those 40 smokers, sample mean, is 172.5. And sigma, the population standard deviation, is known to be 119.5. So since we do know the population standard deviation, we're going to use a z-test. Alright, before we do that, opposite of our original claim is mu does not equal 200. This would be our null hypothesis, this our alternative hypothesis. Alright, so now we pull open our calculator, stat, test. We're going to use z-test. We were given the statistics, so that's what we're going to enter. The value of the null hypothesis is 200. Sigma is 119.5. X bar 172.5. And n is 40. And you want to highlight the inequality in the alternative hypothesis. So we're going to highlight not equal to and hit calculate. Alright, so we've got our test statistic and p-value. Test statistic is negative 1.46. P-value is 0.146. Alright, so now we have enough information to state our initial conclusion. We compare our p-value to the significance level, 0.01, and the p-value is not less than 0.01, so we fail to reject the null hypothesis. We now write our formal conclusion. There is not sufficient evidence to our original claim is the null hypothesis, so we next write reject the claim that, and restate the claim, mu equals 200. Find our critical value and we're done. Critical value for normal distributions is inverse norm. Critical value is in both tails, so we're going to do plus and minus the half of alpha. Alpha is 0.01 divided by 2. Let's plug that into our calculator. Second vars. Inverse norm is 3.01 divided by 2. And we're going to have positive and negative 2.58. Alright.